Today we are going to make a very simple Node.js website and deploy it on a VPS server. But here is the interesting part. You don't need a credit card to pay for your VPS. Instead, we are going to use crypto as our payment method to get the server. I have tested a few different providers like Vultr, Hostinger, BitLaunch, and a couple more. Each of them has its own strengths and weaknesses. Some are fast, some are easy, but none of them feel perfect for what we are going to do today. In the end, I found that UltraHost fits best for this setup. It is affordable, beginner friendly, and most importantly, it supports multiple cryptocurrencies, which make it perfect for this tutorial. Before we move forward, I want to let you know something that might make your life easier. I have also created a written version of this entire tutorial, and you will find the link in the description below. It includes all the commands and steps, so you can literally just copy and paste everything without missing anything. Now to follow along, click the link in the description and sign up on UltraHost. Just fill in your details and sign up. Click on your profile, you'll see a screen like this. From there, select Switch Account. That will take you straight into the main dashboard. Now from the services list, I am going to choose the VPS business package. This one gives us 2 CPU cores, 2 GB RAM and 50 GB NVMe SSD, which is more than enough for a small project like a blog or even a lightweight e-commerce site. If you go for 2-year billing cycle, it drops to around 8.5 per month, which is quite cheap. But in my case, I am going with monthly billing, so it is about $10.5 per month, and I'll just renew it every month. Now this part is important, choosing your server location. Always try to pick a server that is closest to your audience. This helps reduce latency and make your website much faster. For example, I am based in Bangladesh, so naturally the nearest region for me would be Mumbai. But in my case, selecting Mumbai adds some extra cost, which I want to avoid. So instead, I am choosing Singapore. It is still fairly close to my target audience, since most of my traffic will come from Bangladesh and India, and the performance difference won't be too noticeable. Now when you get to the operating system selection, choose Ubuntu. This is the simplest and most beginner friendly option. Click on plain OS, then select Ubuntu, and make sure you go with the latest LTS version. For web hosting, Linux is honestly the best choice. It is free, open source, and on top of that, it gives you strong security and stability out of the box. Next, I am not adding any extra disk space because the default allocation is already enough for what we are building. I also don't need any additional IPv4 addresses. The VPS will already come with one by default after purchase. For SSL, we will select none for now because we are going to set up Let's Encrypt later. That is a completely free and industry standard SSL solution. So there is no need to spend extra money here. Now click continue and you will land on a review screen where you can double check everything before moving forward. Here you will also see a promo code field. Enter WebDevLab, exactly like all lowercase, no space. This will apply the discount. After that, move on to the payment section, and honestly, this is one of the reasons I like this platform. In countries like Bangladesh, a lot of people don't even have international credit cards. That is where crypto becomes Really useful. It lets you pay without all those banking limitations and still get your VPS instantly and continue to check out. Now I ran into a small issue here. A login error popped up. Nothing serious though. I just logged out and logged back in again and it should be fine now. After that, go to the pending payment section. Find your order and click pay now. This will redirect you to a payment gateway called Cryptomus. Now pay attention. This part is very important. You will see a countdown timer, usually around 10 to 12 minutes. So you need to complete the payment within that time. First, choose your currency. I am going with USDT since 1 USDT equals roughly 1 USD. But most critical part here is network selection. You must be extremely careful. If you choose the wrong network, your funds can be lost permanently. There is no recovery. Each blockchain has small gas fees, but for this tutorial I am choosing Tron because it is cheapest and fastest option. Just remember, whatever network you chose here, you must use the same network when sending the payment. And don't close this page. Keep it open until the transaction is fully completed. For payment, you can use a decentralized wallet like MetaMask or Phantom. But to keep things simple and beginner friendly, I am going to use Binance, which is centralized exchange. I am also doing this from my mobile phone to make the process more realistic and easy to follow. Now this is the wallet address I got from UltraHost. And this is exactly where I need to send the payment. Let's switch over to Binance. If you are using other exchanges like Coinbase, KuCoin or Bybit, that is totally fine. The process is almost the same everywhere. If you don't already have an account, you will need to create one first. I already have mine, so I am just logging in. Now the important part is you need to have crypto in your account before sending anything. Since I already have some USDT from a previous purchase, I'll use that. But if you don't have USDT, you have got two options basically. First, you can buy crypto directly using a credit card. Or second, this is popular in many countries. You can use P2P trading. P2P is actually very useful because it supports local payment method like Bcash in Bangladesh, bank transfers and many other regional options. If you are just starting out, I recommend buying a small amount first. Just get comfortable with the purchase process. Once you understand it, you can buy the full amount you need. Now, once your USDT is in your account, you will see it in the asset tab. I currently have 16.2 USDT and that is what I am going to use for this payment. Next, click on send or transfer. Then choose withdraw crypto. Now in the address field, paste the wallet address you received from UltraHost. Make sure you select the Tron network, and this part is very important. The amount must exactly match what you see on the Cryptomus screen. For me, it is 10.83 USDT. Double check this carefully before sending. In some cases, you may need to send a little extra for gas fees depending on wallet, so always review the final amount before confirming. Once everything looks correct, go ahead and click withdraw. After that, Binance will send you a confirmation notification, and you will also receive an email once the transaction is successfully broadcast. Now just wait a minute or two. The Cryptomus page will automatically refresh and you will see your payment status change to paid. Alright, payment is done. So now it is time for the real fun part, accessing our VPS. Go back to UltraHost, open services, and you will see your newly purchased service listed here. Inside the service details, you will find your primary IP address. Copy it. We are going to use this every time we log into the server. Now I am going to connect using my terminal because I am on Linux. If you are using macOS, the process is exactly the same. If you are on Windows, you can use git bash, WSL or putty. All of them work fine. Now we'll log in as a root user. Type SSH space root at the rate your IP address. Press enter and when it asks, just type yes to continue the connection. Next it will ask for the password. Simply copy it from your UltraHost dashboard and paste it into the terminal. And boom, we are officially connected to our VPS server. First, let's clear the screen using clear command. This doesn't change anything in the server. It just cleans up the terminal so everything looks neat and easy to read. Now, before we do anything else, we should always start by updating our system. We'll run apt update and apt upgrade. So what do those actually do? Apt update refreshes the list of available software packages from the repositories. Apt upgrade install the latest version of the software already installed on our system. In simple terms, this makes sure our system is fully up to date with latest security patches and improvements. This process might take a few minutes, so just let it finish. Now for security reasons, we should avoid using root user directly. Instead, we are going to create a new user. I am going to create a user called Sion using this command add user Sion. After running it, the system will ask you to set a password. Type your password. Don't worry if nothing shows on the screen while typing. That is normal in Linux for security reasons. Then it will ask you to confirm the password by typing it again. After that, it will ask for some details like full name. For me, I will enter MD Sion. For everything else, you can just simply press enter and skip it. Now we need to give this user administrative permissions. We do that by adding the user to the sudo group. Why? Because the sudo group allows a user to run commands with root level power. Basically full control when needed. Next, we'll switch into the new user account using su space dash space Sion. This means switch user and load the full environment of Sion. Now let's check what is inside our current directory using ls-la. So what does this do? ls is equal list files and folders. -L shows detailed information like permissions, size, owner. -A includes hidden files too. So basically it gives us a complete view of everything in this directory. Now let's create a new folder using mkdir.ssh. This creates a hidden folder called .ssh. So what is this for? The .ssh directory is used to store important SSH related files like public keys, private keys, authorized keys. In short, it is where all SSH authentication data lives. Now on quick note, if you can't see some commands or something looks missing on the screen, don't worry about it. It might be an obvious recording issue. If that happens, you can always follow the written tutorial linked in the description. But overall, everything should be working fine. Now we need to create a file called authorized_keys inside the .ssh folder. This file is very important. It tells the server which SSH keys are allowed to access this user account. To create and open it, we'll use nano.ssh/authorized_keys. Now, Nano is a simple terminal-based text editor. Think of it like Notepad, but inside your server. Next, we need to generate an SSH key on our local machine. Run this command ssh-keygen-t ed25519-c and double quotation mark your email address. This command works on Linux, macOS and Windows as well. So what is happening here? SSH keygen generates a secure SSH key pair. -t ed25519 uses a modern secure encryption type. -c adds a label, usually your email, to identify the key. After running this, you will get three important files: id-ed25519, your private key, keep this secret; id_ed25519.pub, your public key, this is what we share; known_host, this stores known servers you have connected to; cat ~.ssh/id_ed25519.pub. This will print your public key on the screen. Now copy this key from your local machine and paste it into the server inside the authorized keys file we opened earlier. After pasting, save and exit Nano. Press Ctrl+S to save, press Ctrl+X to exit. Now we need to fix file permissions. This is very important for security. First, change ownership of the .ssh folder. Sudo chown-r //:/.ssh. So what does this do? It means we are giving full ownership of the .ssh folder to the user Sion. Whenever you use sudo, it will ask for your password. That is the password you set when creating the user on the server. Next, we'll set proper permissions. Sudo chmod 700 ~.ssh. This means Only the owner can read, write and access this folder. Then sudo chmod 600 tilde key /ssh authorized keys. This means only owner can read and write this file, no one else can access it. This is critical. SSH will refuse to work if permissions are too open. Now we exit the server by using this command exit. At this point we can log in again, but this time using our new user instead of root. SSH sion @ your primary IP address. From now on, this is our main and secure way to access the server. Now that we are logged in as Sion, we can disable root login completely for better security. We'll edit SSH configuration file using sudo nano /etc/ssh/sshd_config. Inside this file, press Ctrl W for search and write permit root login. Set it to no. This means root login is completely disabled. No one can directly access the server as root anymore. To save, Ctrl+S and Ctrl+X. Now again search for password authentication. We want to disable password login and allow only SSH key authentication. So we remove the hash. If it is commented and set it to no, this means no password login allowed. Only SSH key access is allowed. This makes the server much more secure against brute force attacks. To save, Ctrl+S and Ctrl+X. Now that we have updated the SSH configuration, we need to restart the SSH service so all changes take effect. We'll run sudo systemctl restart SSH. So what does this do? It simply restarts SSH service in the background and applies all the new security settings we just configured. Now it is time to secure our server properly using a firewall. If you are not familiar with firewalls, think of it like a security guard for your server. It controls who can enter or who get blocked. I have created a 1-minute shorts on firewall. If you don't have any idea, then you will be cleared after watching that short. The link of that short will be in the description. For this, we are going to use UFW, uncomplicated firewall, which is most popular firewall tool on Ubuntu. The good part is it usually comes pre-installed. First, let's enable the firewall. Sudo UFW enable. This turns the firewall on and makes sure it starts automatically after a reboot. But here is something very important. If we enable the firewall without allowing SSH first, we could lock ourselves out of the server. So next we allow SSH access. Sudo UFW allow SSH. This ensures we can still connect to the server remotely. Now we set default rules for better security. We deny all incoming connections by default. Sudo ufw default deny incoming. So what does this mean? It means no one can access our server unless we explicitly allow it. Now we'll allow all outgoing traffic. Sudo ufw default allow outgoing. This lets our server freely access the internet, like downloading packages or connecting to API. We also explicitly allow OpenSSH again for clarity and safety. Sudo ufw allow OpenSSH. This ensures SSH access is properly permitted by the firewall rules. Now we also open the default SSH port manually. Sudo ufw allow 22-TCP. This allows traffic through port 22, which is standard SSH port. At this point, our server is much more secure. Only necessary traffic is allowed, but everything else is blocked by default. Finally, let's refresh our package list again, just to make sure everything is clean and updated. Sudo apt update. Now let's install Nginx, which is going to handle our web traffic and act as a reverse proxy for our Node.js application. So basically, Nginx will sit in front of our Node.js server and manage incoming requests efficiently. This is how most production servers are structured. To install it, run sudo apt install nginx-oi. The oi flag simply means we are automatically agreeing to the installation prompts. So it installs without asking for confirmation. Just wait a minute, the installation will complete in the background. Now let's quickly verify our firewall rules. Sudo ufw status. This will show all active firewall rules and confirm everything we configured earlier is working properly. Next, let's check Nginx itself. To see its status, run sudo systemctl status nginx. This will tell us whether Nginx is active and running correctly. Now to make sure Nginx automatically starts every time the server reboots, we enable it. Sudo systemctl enable Nginx. So what does this do? It basically registers Nginx as a startup service. So you don't have to manually start it after every reboot. If you ever need to restart it manually, you can use sudo systemctl restart nginx. Now let's test if everything is working. Open any browser and enter your server's IP address in the URL bar. If everything is correct, you should see the Nginx welcome page. This means our web server is successfully installed and running. Now let's move on to installing Node.js, which is what we'll use to run our backend application. We are going to create a simple Node.js server and connect it with Nginx later using a reverse proxy. Instead of installing Node.js directly, we'll use NVM, Node Version Manager. This is much better approach because it allows us to easily switch node version later if needed. To install NVM, run this command. So what is happening here? Curl downloads the application script. Pipe bash runs the script directly in the terminal. This install nvm on your system automatically. After this, we'll continue installing Node.js using nvm and setting up our actual server. Now that nvm is installed, we need to load it in our current terminal session. Because without this step, the nvm command won't work immediately. So run this command. So what does this do? It simply activates nvm in the current shell. So we can start using it right away without restarting the terminal. Now let's install Node.js. We'll install version 24 using nvm. nvm install 24. This downloads and install the latest nvm version along with npm, which we'll use for managing packages. Once installation is done, let's verify everything is working. Node-v, npm-v. So what we are actually checking here? Node-v confirms the Node.js version. npm-v confirms the Node package manager is installed. If both commands return version number, we are good to go. Now we also need Git, because in real world development we always use version control. First update the package list, sudo apt update, then install Git, sudo apt install Git. After installation, verify it with git -- version. This ensures Git is properly installed and ready to use. Now let's create a very simple Node.js server. We'll use the official example from Node.js. This is just a basic server that we'll later deploy behind Nginx. Now let's organize our project properly. First, we'll create a folder for our Node.js app, which is node-app. Then move into the folder cd node-app. Now we'll create our server file using nano editor, nano server.mjs. So what is nano again? Now paste the Node.js server code we copied earlier into this file and save it. Once it is done, we can start our server with node server.mjs. If everything is correct, we'll see listening on 127.0.0.1:3000. So what does this mean? It means our Node.js application is running, but it is only accessible inside server, not publicly it. That is exactly where Nginx comes in. Now we are going to set up Nginx as a reverse proxy. What is a reverse proxy? In simple terms, Nginx will receive public traffic and forward it to our Node.js server running on port 3000. Let's create a Nginx configuration file. Sudo nano /etc/nginx /sites-available / name of the file, which is uncharted with sion API. Inside this file, we'll add our configuration. Just copy this from the blog post and paste it here. So what is happening here? Nginx listen on port 80, which is default HTTP port. Server name defines the domain that will point to this server. Inside location / we are forwarding all requests to our own Node.js app running on 3000 port. The proxy set header makes sure user information like IP and host is correctly passed to Node.js. Now we need to activate this configuration by creating a symbolic link. Sudo ln-s etc /nginx /site dash available /uncharted dash with dash Scion dash API space /etc /nginx /sites enabled. So what does this do? It tells Nginx, hey, this configuration is now active. Start using it. Next, we remove the default Nginx configuration because we don't need it anymore. Sudo rm. This rm command is to remove anything from the server. /etc /nginx /sites dash available /default. Now we also need to remove the default site from the enabled Nginx configuration, because even if we removed it earlier, Nginx will try to load it from the active directory. So run sudo rm etc /nginx /sites dash enabled /default. Now let's verify the configuration. Sudo nginx -t. This time it should pass successfully. So what is this command doing? It is basically Nginx doing a final check, making sure there are no syntax errors or broken configurations before we apply anything. If it says everything is okay, we are good to go. Now we reload Nginx to apply all changes. Sudo systemctl reload Nginx. So what is difference between restart and reload? Restart stops and start the service completely. Reload just applies configuration changes without fully stopping Nginx. So reload is faster and safer in production. Now let's move to domain setup. I already have a domain in Cloudflare. But if you are using Namecheap, GoDaddy or any other provider, the process is almost the same. What we are going to do is create a subdomain for our API. So I am going to log into Cloudflare, go to my domain dashboard and open the DNS record section. Now I'll create a new A record. Why A record? Because we are pointing a domain name directly to our VPS IP address. Here is what we configure. Name will be admin.uncharted. This becomes admin.uncharted.webdevlab.org. IPv4 address. Paste your VPS IP address here. Proxy status, turn it off. DNS only. This is important because we want direct server access for now while testing. On saved, Cloudflare will start routing this subdomain to our VPS. So now in theory, this URL should work. admin.uncharted.webdevlab.org. But if you try opening it right now, it won't work it. And that is actually expected. Why? Because our Node.js server is currently stopped on the VPS. So Nginx has nothing to forward request to. Now before we run our Node.js server again, we are going to secure everything with SSL using Let's Encrypt. This is important because right now our site works over HTTP, but we want everything to run over HTTPS, which encrypts all traffic between the user and the server. So instead of plain HTTP, all requests will be secure and protected. First, let's install chatbot and the Nginx plugin. Sudo apt install chatbot python 3 chatbot nginx -y. If you see any prompt about kernel updates or additional packages, just confirm it. That is normal during installation. Now we'll generate and install the SSL certificate for our domain. For that, run sudo chatbot -nginx the URL, which is admin.uncharted.webdevlab.org. So what happens here? Chatbot will automatically verify your domain, generate SSL certificates, configure Nginx to use HTTPS, and during the process enter a valid email address, press Y to agree to the terms. If it asks about email updates or newsletter, you can choose no. Once everything is done, we'll see a success message saying HTTPS has been enabled. Behind the scenes, chatbot create two important files: fullchain.pim, your SSL certificate chain, and another one is privkey.pim, your private key. Those two files are what power your HTTPS security. Now let's bring our Node.js server back online. Node server.mjs. Just to keep things simple, we are not going to use a process manager like PM2 or a database in this tutorial. So you understand the core flow. Now open your browser and visit the domain, and if everything is correct, you should see Hello World. Your Node.js app is now hosted on VPS, secured with SSL, running behind Nginx reverse proxy, accessible through a real domain, and that's it. You have just deployed a production style Node.js server from scratch using a VPS and crypto payment. If you got stuck anywhere, you can always follow the written blog version linked in the description. If this helped you, consider liking the video, leaving a comment and subscribing. It really helps the channel grow.